Hello everybody. My name is Sadeh and I am the CTO for Income Data Systems. So excited to have you with us today here for a session called Building a Browser-Based Search and Impact Analysis using Zowe as a Bridge. Indeed, we're going to go through this session looking into these three aspects of this process. We have a browser where we want to provide modern, intuitive, and familiar user experience. Search and impact analysis, which is handled by the application server, must be fast and has to be accurate in order to be useful and reliable. Then we have Zowe. Zowe is used as a standardized and secured method to handle content retrieval from the mainframe. On the ends of this process, on one side we have the mainframe. And the mainframe is where the information resides. This is where we have code, jobs, batch environment, online environments, logs, database schemas, and lots of other assets. We are going to use Zowe to retrieve that information for the application server to process and prepare that information for users to be able to access it from a browser so that they can get understanding, do documentation, create artifacts like reports and exports, and at the end, make decisions. But there is also a bigger picture here. An enterprise has assets and systems beyond the mainframe. And so for the record, we also have connectors that specialize in how to connect to those systems, whether it be distributed code repositories like Git and others, database schemas, logs, tickets, and lots of other things. There are also APIs, and these are the same APIs that the browser application is using, but they can also be used by services and DevOps in order to enable automation, reporting, notifications, integration with DevOps channels, and enterprise applications can also be created in order to implement any specific enterprise logic. But for the purpose of this lecture, we are going to stay within the scope of the mainframe to users. Let us now do a close-up into each one of these three elements, and let's start with Zowe. For Zowe, we have a connector. This is the bridge. It is a GUI to configure a service that allows organizations to retrieve the information from the mainframe. This is where we can configure the credentials of a mainframe user and have it be authenticated and authorization be implemented so that user can only access resources that it can access on the mainframe. We can also list the members of sequential and partitioned datasets and configure their extraction. There is also an option tab, and maybe the more interesting one here is the input encoding. This is where we can configure the code page to use for the content extraction. So if we're extracting members that have in them code pages for, let's say, Hebrew or other language, we can configure it here and make sure that the information is retrieved in its proper, readable, understandable encoding. These are the Zowe APIs that the Zowe Connector is using in order to enable its functionality. From the security controller, we're using the logging, query, and ticket methods. And this is how we're implementing the functionality of taking mainframe credentials and getting them authenticated. Once credentials are authenticated, we're using the datasets controller, and from that controller we're using the content, members, and filter methods in order to list the members of datasets and retrieve their content. Next, we'll take a close-up into the search and impact analysis aspect of the process. Search must be fast, so that means that we have to index information as it being retrieved from Zowe. Now, we're all used to having search be a very integral part of our daily work. But in order for us to really rely on it, it has to be fast. If a search takes 4 hours to do, we're not very likely to do it very much. If it takes less than a second, we are very likely to use that all the time. The search has to be relevant. So first of all, what it means is that the information must be up to date. And that is the responsibility of the Zowe bridge to make sure that that happens. Also, from the browser experience standpoint of this, we have to make sure that users are able to narrow down what they're searching within, because remember, we're talking about a system that has all of the assets of an enterprise. So that might mean narrowing the search to just production, or just development, or just test, or maybe just a specific PDS or a language. Another type of filter that users need is a post-search filter. We executed a search, we got results, but we still need to be able to work with those results and filter them down. The search also must be intuitive. And so the first thing that means is using a familiar experience. Browser-based means that most, if not all, of the users will be untrained. A familiar experience ensures that a new user can log into the tool for the first time and feel comfortable. Feel like there's enough element that they've seen before and enough things that work in a way that's familiar for them to be able to get up to speed without any training. Another way to make things more intuitive is to provide users with tools. And so in our case, there are tools that help users compose more complex queries. Now, any user can probably log in and do a search for a word or a phrase. But in order to enjoy more advanced capabilities of the search and the impact analysis, these tools make sure that users can do that. And we also have AI and HI, human interface. For example, AI is being used when a user searches and doesn't find anything. We implement artificial intelligence in order to bring suggestions to the user for a search that is the closest possible match to what they looked for that actually did find results. Human interface is implemented through the existence of a chat experience. As humans, conversation is the most familiar interface that we use, and having that exist in the browser experience makes sure that users can get to more advanced capabilities of the tool in the way that is most convenient to humans, which is a conversation. Impact analysis. We have search-driven analysis, and that is the kind of impact analysis that is driven by search. For example, find all of the places where a certain field is being used. References analysis. We have to take the information that comes from Zowe and build the call tree. That can be for a single program or maybe for an entire subsystem. We are also taking that referential information and are creating an experience in the browser where hyperlinks are being used. So the user maybe is looking at a COBOL program and the COBOL has a copy statement and there's a hyperlink from that line to the copybook that is being mentioned on that line. Field analysis. The first capability is to simply search for fields. So as information gets loaded after it's retrieved through Zowe, parse and harvest from it all of the fields and their metadata. Once we have that, we can allow users to search across that and find all of the places where there's a field with a specific name or specific definition or specific value type or default value and so on. We can also visualize the flow of one field to the other using field tracking. Another kind of analysis that we enable is a runtime analysis. We are expanding the COBOLs and the JCLs, and that allows users to do searches on runtime values. So for example, if we expand a JCL, then now we can look for all of the DSNs that are being used there. We can search for symbolic substitutions after they happened, overrides, and all of that. That analysis is also important for other analysis that is happening on the server. For example, in order to get a true picture of field tracking in COBOL, the COBOL has to be expanded. Code analysis is another type of analysis that is enabled by the application server as information is being loaded. One type of that analysis is the control flow, and the control flow is a visualization of a program structure. So someone who just joined the company, or really anyone, can look at the structure of, let's say, a very complex COBOL program and gain a much better understanding of it. Another type of analysis that's available under that category is the complexity analysis. And that analysis is assigning a metrics of how complicated a program is. So if someone is wanting to tackle a rewrite or a change of that program, they know what they're about to handle. A project manager can better prepare for a project and assign more complex programs to more experienced developers, and so on. Next, we'll take a close-up into the browser experience. And this is really where everything comes together. So the information that comes from the mainframe through the Zowe bridge and then processed for impact and analysis and search on the application server is being made available to the users in the browser. We're going to look at an example where we wanted to change fields that are containing the name tax-amount, AMT. So this is the main search page. And you can see how it feels very familiar. Yes, there might be some advanced features here and things that are maybe unique to this application, but for the most part, if this is the first time that I'm looking at it, I can understand that there's a box for me to enter what I'm searching for and a search button that I can click on. Now, we talked about these tools that can help me compose more complex queries. One of them is these fields. So I can use this without understanding the specific query language for this application and search for, let's say, a program name. Or in this example, I can narrow my search to COBOL, procedure division, and only within code. So that's what I'll do. So this created a query that searches only in COBOL procedure division within code lines for this field name. Another ability that I have here, another tool, is synonyms. So if an organization creates a synonym dictionary for their COBOL fields, then I'm able to search for tax amount as a synonym and find all of the different implementation or variations of it. There's also support for regular expressions. What we're going to do, the search that we're going to execute now, is actually going to use a tool called Save Queries that allows users to create either private or shared pre-created queries. In our case, we're going to execute a search called Field Use of Dynamic Business Rules. We're going to put the field name that we're looking for. And the search that we're going to perform is going to search within code lines for the word if, then, or the word else where they're preceding the field that we're looking for. So we search and we found 29 documents or programs. It took 0.05 seconds. But what I want to do next is I want to actually see the actual lines in the code where results were found. So I'm going to use something called all hits with a 2-line preview. And this shows me all of the lines in the code where search hits were found, but it gives me a preview of 2 lines before and after so that as a developer, I can understand the logic. I can get some context about not just the lines where search were found, but what they're being used for. That's a search-driven impact analysis. But what I want to do next is I want to look beyond just the programs where this field was found. I want to find the subsystem that is impacted by this change. So I'm going to use a search result action called Infinity Search that is going to do just that. And you can see that instead of having results just in COBOL, I now have results in JCL, PARMS, and PROX. And so this gave me the entire subsystem, the COBOL programs that have the fields that I want to change, and the programs that are calling them, and the other programs that are calling, and so on. I can export this, and maybe that's what I want to do. Maybe that's the report, the artifact that I need to create. So I can create a document and choose the format and decide which export folder to put it in. And all of my exports, as I do my work, can go into that one folder. And at the end, I can email it to users. I can download it. I can view it myself. I can also use another search result action to actually visualize the call tree in this subsystem. And that's what I'm going to do. So the search result xref is showing me all of the search results and how they interact with each other. Next, I want to look at one of the results from the search results. So this is a COBOL program, and you can see that it's expanded. You can see that there's a copybook that was embedded here within the original COBOL. You can also see the hyperlinks that I was talking about earlier. So there's a copy statement here to a copybook. So as a user, I can click on it and I can jump and open another tab in my browser with that copybook. There are some quick actions that are implemented through icons that I can use up here. So I can do a quick search within that program that I'm looking at and get a summary at the top. I can view the complexity data. I can also select text and get a context menu that lets me execute actions on that selected text. From here, I can document the use of a business rule if that's what's happening here. I can edit to catalogs that my admin can create. What I'm going to do is I'm going to create an annotation. I'm going to add some tags about this portion of code within this program. I'm going to add some comments and I'm going to save it. And from that point, it's available for other users to search, view, and anybody that participates in this project can make use of this. The next thing that I want to do is I want to use again that referential analysis and the call tree that the application figured out for me when information was digested. So I'm going to use from the actions above the view document the cross-reference. And what the cross-reference gives me is a diagram that shows me the call tree for this program that I was on. So the pink here is the COBOL program that I was looking at. And I can see that there is a scheduler that is calling a job, that is using a proc, that is using a parm, that is using a DSN, and the proc is also executing this COBOL that I was looking at, and I can hover over the line and see exactly the line that's happening. There's also a Java on my Git environment that is through a transaction calling this COBOL program. And of course, it's a COBOL, so it's using a copybook, and the copybook is using a DB2 layout. I want to show you how an expanded JCL looks like, so I'm going to click from here on this expanded JCL and view that program. And you can see that this JCL was expanded with the procs that it's using, but we also went further and we have the overrides. So here's a DSN that's being used through an override. We're resolving symbolics. And here's an example of also a card that is being used as well. The last action that I want to show you here on this viewed program is control flow. And control flow is that program structure that I was talking about earlier. So here it is, and I am looking at this paragraph and I can see how it flows. I can move over to the source code tab and I can interact with the source code. So I can see in green here which lines of code are currently being represented in the diagram. I can click on a line and have the corresponding element in the diagram get highlighted or go the other direction. So this is the control flow. When I view a program on the side, I have insights. And the one that I want to highlight right now is the COBOL Field Explorer. I can see all of the fields that were found in this COBOL. From here, I can also click on any of them and it takes me to the field tracker diagram. So this shows me the flow from one field to another or value to field. It visualizes that for me. The last thing that I want to show is that chat experience that we implemented into the web experience. So from here in this example, I'm going to choose one of the categories, which is going to be code analysis. And I'm going to say that I want to do COBOL Field Explorer. It's going to ask me for the name of the field. So I'm going to say containing tax amount. It's going to take me through a series of questions. Do you want any specific field type? I'm going to say no, any. Do you want to search on that field as a synonym? I'm going to say no. Do you want to search for this field in a specific program? No, any program. I want to find all of them. Any specific field usage, like add or compute? I'm going to say any. And lastly, any specific field definition. And again, I'm just going to say any. So that's going to open the Field Explorer application. And again, I got there without even knowing that it exists or what I need to click on throughout the application in order to get there, or even how do I need to use this application if I did find it. From here, I can continue filtering if I want to. So I can filter by definition or by value type or default value. So this is at the end going to list all of the fields that match my search. From here, I can either export this list because maybe that is the report that I'm looking for. I can also select items and from here generate that field tracking diagram that we just saw or a more comprehensive report as well. So this was a quick walkthrough the browser experience that is enabling users to access information that is retrieved from the mainframe through Zowe in order to perform impact analysis, searches, document, create artifacts like reports and exports, and make decisions. We will now open this to questions and answers.